there's an emergency. We need you immediately. So this is it.
This man has inhaled an extremely toxic gas that has caused his organs to inflate into exact geometric shapes. We need to operate him immediately and calculate the damage and make sure he's okay.
Sounds good, and I'm confident that I'm totally qualified for this.
Alright, let me go get Dr. Fluxgood.
Now, what we're going to need to do is make a certain amount of incisions. So I have a diagram right here. What we're going to need to do is make 3 incisions on your arm right there. Then make incisions at critical points of your abdomen, all over the place. Then we're going to have to do somewhat of a lobotomy maybe later on. And then several more incisions right here, in the chest area. Just among your vital organs, basically. But don't worry, sir. We have the best anesthesiologist in the business. Can you come in, please? Sir, this is Dr. Fluxgood. Hi, how are you? She's been a member of this hospital for 30 years. She is a true professional, and I can guarantee she will make it so that you won't feel a thing.
Go.
Thank you, I'm so relaxed, doctor.
Yeah, well, here's the thing. Unfortunately, this hospital has had to go under some significant budget cuts, and while going through the pink slips, she was actually first on the chopping block. Yeah, so Dr. Fluxgood, we appreciate all the work you've put in here. Best of luck to you in the future.
Oh, well, thanks. Yeah, it's all good.
Yeah, definitely. Yeah, you know, it just happens. Have a good day.
Thanks, bye.
Okay, peace. So, sir, with that being said, we're gonna have to go through this naturally.
Oh my god, doctor, that's a perfect sphere. Okay, cool. Okay, nice.
Well, yes, it is a perfect sphere, and from my experience, this particular sphere would be related to the equation x squared plus y squared plus z squared equals 25. See, this is the equation of the sphere with radius 5 because 25 is 5 squared. And what I know is that in order to find the volume of the sphere using integration, we must use a triple integral and use spherical coordinates, which include the coordinates rho, which measures the radius. We have delta phi, which measures the angle from the vertical component of the sphere, and we have delta theta, which basically measures the roundness from the side of the, right?
Got it, yeah.
Yeah, you're guys doing, you catch on this more than I do, right?
Yeah.
And in order to solve for spherical coordinates, we need the centerpiece, rho squared sine phi. I've never forgotten that. So, pretty simple. Phi, the coordinates are 0 to 5 because the radius is 5. For phi, it would be 0 to pi because this measures the sphere from here to this part, the vertical roundness. And then d theta, we just have to calculate the components from around the horizontal axes. Exactly. 0 to pi. So let's see here. So basically, 1/3 rho cubed sine phi. That's right. 0 to 5. Let's put back our original coordinates. 0 to pi. And we have d theta. This ends up being 0 to pi 2 125 over 3 times, and now we're going to integrate sine phi, and the sine.
That's minus cosine phi?
Exactly.
Right.
Good job, my young chap.
Thank you.
Delta phi, delta theta, and we still need to calculate this from pi to 0. And so that would, over here, eventually equal rho 2 pi 125 over 3 of 1 minus 125, 3, negative 1 delta theta, and that will give us
250.
250.
Yeah.
We're almost there, we're almost there. We're gonna save this man's life right now. We have theta from 2 pi to 0, because I just integrated that really quick. And this gives us, wait for it, 500 pi over 3
Got it.
inches cubed. Because remember, we're doing real live objects now. Okay?
Alright, let's note that down.
Let's do this.
And make sure he's fine. We got that.
Alright, we got this.
The stomach looks all in check. So we're just gonna place this back in here.
Thank
That's
you
good.
guys.
Okay, now we have to focus on the heart. Very good, very good, and oh no.
Oh. That looks like a cylinder to me, isn't it?
I was afraid of this. No. Sir, I have always been perplexed by the cylinder because it's quite obvious that we need to use cylindrical coordinates here, as you can see.
I'm really bad at that. You better help me with that.
Yes. See, it's quite obvious that we need to use the coordinates dr, d theta, and dz. For dr measures its radius, d theta measures the radius wrapped around the can, and dz would be
The height?
the height of it. Exactly. But first, you need some sort of centerpiece so that you can transition from x squared and y squared to cylindrical coordinates. I have no idea. It's like, what could it be?
Like
What could it be?
R, like the radius, like R? I think that would work.
R.
Yeah. Like R, dr, d theta, dz.
Oh man, you're a genius! Of course!
Okay.
It's because it's Jacobian.
Right.
Many men have talked about this, but none of them have ever proven it. Obviously, whenever you're doing cylindrical coordinates, transition x to r cosine theta and y to r sine theta. Therefore, if you take the Jacobian, it's basically the vector of r, x, the vector of theta. And this, we put this into a matrix, cosine theta, because that's the derivative of this, sine theta, because that's the derivative of y, and then we need the theta derivatives, which would be negative r sine theta, and r cosine theta, which gives us clearly r cosine theta squared minus negative r sine theta squared,
Which is R.
which is an identity, exactly, which equals r. You're a genius, man.
Right.
We can totally solve this now. I'm going to shortcut my way through this. It's basically going to be, let's see, 0.5, 0.2 pi. Let's integrate
That's
dr first.
R squared
I have
over.
r squared, 0 to 2, d theta dz, which obviously equals 5, 0 to 2 pi, so obviously equals 1/2, 2 squared,
That's 4.
that's 2.
2. Yeah.
2 d theta dz. And since there are no longer theta and z coordinates in here, we can just shortcut. So 5 to pi, zeros cancel out. So we would have 5 times 2 pi times 2 equals, what is it, man? What is it, man?
That's
What is it, man? We have
4.
this
20
guy's gonna die. It's what?
20 pi.
25.
20 times 5.
25, exactly!
There you go. We
We've
found
done it!
it.
We've done it! We've
You're
done it!
fine, bro.
You're a genius, man! You're a genius!
Don't
You're a
worry.
genius! You have just saved this man's life.
Nice.
I swear, I'm so impressed. It is within my power to make you an official
Oh
MT.
my god. Oh my god. This is the best thing in my life. Thank you so much, doctor.
No. Thank you, man, for you have saved this man's life.
Alright, everything seems good, doctor. He seems okay. All the organs are back. Let's just remove the tape and let him go. Alright, you're all set.